Hey guys, this is Miss Johnson. I've been promising you a video on ions and isotopes all week, so here we go. Let's get started. In order to first start talking about ions and isotopes, I think that we should review subatomic particles and how we find them before we start talking about how to change them. So if you remember back a long time ago, we talked about three subatomic particles. Three subatomic particles. And those particles are protons, neutrons, and electrons. I know that on your notes you had to fill out a chart, but I'm going to quickly write one of those down again just to making sure that we're all up to date. If we talk about protons, neutrons, and electrons, let's talk about where they're found. Okay. Protons and neutrons are both found in the nucleus. Okay. Electrons are found in the cloud, and they're found in the cloud because they have no mass. Okay. However, protons and neutrons, do have mass, so therefore, that's the only part of an atom that has any weight. Okay, so whenever we talk about the mass of an electron, we're only talking about protons and neutrons. So I put this neon panel into your notes, and I wanted you to write it down and label them as we went as a review. Okay, so now let's talk about how we can find protons, neutrons, and electrons by looking at one of these panels on the periodic table. And if I were you, I would make sure that I wrote one of these down on my periodic table for my final exam. Just as a quick reference for you to take a look at, I would pick your favorite element and find its protons, neutrons, and electrons and label it out just as a quick reference so you can look back at it. Okay, so this very top number is the atomic number. Now, I don't want you to remember it as an atomic number because don't forget, they can be flipped, and we're going to talk about that in a minute, okay? The cases where those get flipped. But just remember that atomic number is typically the whole number, okay? That atomic number is going to tell you two very important things. It's going to tell you the number of protons and electrons. And don't forget, if you are looking at an element on the periodic table, protons equal the number of neutrons. Those numbers should be the same, okay? Here in a minute, we're going to talk about what happens when they're not the same. Okay, so the last number down here at the bottom, like I said, I don't want you to remember that they're on the bottom. Just remember this is the one with the decimal, is the atomic mass or the atomic weight, okay? And like I said, whenever you think of the mass, think of the only two subatomic particles that has a mass. The only two that have a mass are protons and neutrons, okay? So in order to find the number of neutrons, you're going to take this and subtract it by this, okay? So you're just going to subtract those two numbers. So if I'm going to find the number of neutrons of neon, I'm going to, oops, my back accident. You're going to say 20 subtract 10 gives you 10. So neon naturally has 10 neutrons. Okay, so if you have any questions about that, raise your hand now, and I'll be happy to come around and help you. Okay, so for those of you that are still on track, we're going to move on to subatomic particles. So really quickly, we're going to run through this. Let's look at A. A has a negative charge, so that would be an electron. You also know that's an electron because it's found here in the shells, or the clouds, or the orbitals, whichever one you like to call it. If we take a look at B, B is pointing to here in the middle, in the nucleus. We can see that there's no charge on it, so that would be a neutron. And last but not least, we have C is pointing to a positive charge, and that would be our protons. Okay, let's quickly fill out this chart just to review. Protons have a positive charge, neutrons have no charge, and electrons have a minus charge. Once again, if I were you, I would definitely make sure that this is on my periodic table for my final exam. Only two of these particles have a mass, and we need to keep that in mind. at all times. So protons have a mass and neutrons have a mass. Electrons do not. They're light as a feather. They live in a cloud. They wouldn't have a mass. Okay. So where are the protons found? These are found in the nucleus. Okay. Oops. Sorry, my computer is doing something crazy. Go back. There we go. And where can neutrons be found? If you take a look up here in our diagram, it's also found in the nucleus. Okay. Think about it, guys. Protons and neutrons are heavy, so they're going to sink down into this nucleus. They're going to be super heavy, okay? Where electrons are light as a feather, so they're going to float up here in the cloud. And electrons are found in the clouds. You can say shells, you can say orbits. I typically say clouds or shells. Last but not least, how can it be found on the periodic table? So this is just a review of what we learned a second ago. So we found protons by looking at the atomic number. And for neutrons, we find that by looking at the mass, subtract protons, or you could say mass, subtract atomic number. Hopefully you realize that those are both the exact same thing. And last but not least, you find the number of electrons by also looking at that atomic number. Okay? So now that we've reviewed that, let's move on. We're not going to go over this. Now let's get down to the nitty-gritty about changing the number of electrons and neutrons. Okay? So we've just talked about how to find our protons, neutrons, and electrons in a normal element, okay? But we know that all elements are not normal, okay? Lots of elements want to do funky things, okay? For instance, let's look at an ion. An ion is an element that has a different number of electrons. And what that means is that the protons does not equal the number of electrons. They're not equal, okay? So, if we think about this logically, think about protons have a positive charge and electrons have a minus charge, okay? We can never change the proton number, okay? That's that atomic number. We can never change it. So, for instance, let's think about carbon, okay? We know that carbon has 6 protons, okay? And it's supposed to have 6 electrons. Can you see how there's 6 pluses and 6 minuses? Those cancel each other out, and it makes it a neutral element, okay? I also like to think about this like an electrical charge. We know that positives and negatives always attract each other. The same thing here, okay? So these guys always are going to be attracted to each other. So I've got now let's talk about an ion, a carbon atom. Let's say that it has a charge of +4. Also, notice how that +4 is written as a superscript. It's not written great big out beside it. It's wrote as a little tiny charge up here at the top. Okay, so I have a carbon +4. What that means is that this carbon has lost 4 electrons. And I know that's a little confusing to some people, so I'm going to show you how I work this out. Okay, we know that carbon is supposed to have 6 protons. Okay, that can't change. It's supposed to have 6 electrons, but this says it's got a +4 charge now. In order for this to have a +4 charge, it means that I have to have lost those electrons. So instead of 6, sorry, I just had like a brain fart. So instead of 6 electrons that I'm supposed to have, I've lost 4. So that means I'm down to having 2 electrons. Okay, so this means that I now have more positives, okay, and I have 4 extra positives. That's where that +4 comes from. Sorry that I had a brain fart. I'm trying to watch TV and film this at the same time. I gotta turn off the TV. Okay, sorry, that was a little side note. The next question says, what is the charge of an electron? Okay, so we just reviewed that. It has a negative charge. The next question is, why would an element want to gain or lose an electron? Okay, that is a great big lesson. Okay, that was a huge chunk of chemistry. We talked about the whole purpose. What is the goal of all atoms? The goal of all elements is to have a full outer shell. Okay, a full outer shell. And we like to say that it has a full outer shell, and that means it's fat and sassy. It's completely happy. It wants to be left alone. He doesn't want to bond with anybody. So that's the whole purpose. So if we look at carbon, and carbon has 6 electrons, it would want to gain or lose 4, so it drops down or completes an outer shell. So if we take a look at this carbon right here, it's actually going to get rid of those 4 valence electrons and drop down to the very first shell, and that very first shell can only hold 2 valence electrons, so then that carbon would have a full outer shell. Okay? All elements on the periodic table are neutral. It's not until you find one that's not on the periodic table that it's not neutral. And if it's not neutral, like I said, it will have this charge up here in the upper right-hand corner. The next question is, but when they gain or lose electrons, they become charged like a magnet. That is true. Okay. Whenever it becomes charged, it's going to want to find its opposite charge in order to cancel each other out. And what I mean by that is, let me erase this up here. So think about sodium. Okay, sodium has a +1 charge. Dang nabbit, I don't know why it keeps doing that. Sodium has a +1 charge, okay? So that means he wants to get rid of 1, where fluorine has a -1 charge. And this is saying, oh, wait a minute, I would love to take that electron off your hand so that I can now have a full outer shell. So notice how this has a plus and this has a minus. They would be attracted to each other, kind of like an electrical charge, okay? Making sure you write those oxidation numbers across the top of your periodic table. If it loses an electron, it's going to become a cation. That would be our sodium here. Most cations are metals. If they gain an electron, right here, they gain an electron, they now become overall negative, and that would be an anion. That is most nonmetals. Okay, so now let's flip script and start talking about isotopes. So an isotope has nothing to do with electrons, okay? Isotopes is when we change those numbers of neutrons. And remember how we find neutrons. You say mass, subtract protons, okay? So we know it's a different number whenever we compare it back to the periodic table, okay? Why would it have a different number of neutrons? It would have a different number of neutrons if its mass is different. Remember that on the periodic table, that's just the average mass. But we're not all average in the world. There's some that are heavier, there's some that are skinnier. So just know that on the periodic table, that's the average. Does this make it have a charge? Okay, let's look up here. We're talking about a change in the number of neutrons. Do neutrons have a charge? No, they're neutral, so this would not make an element have a charge. How can we tell if an element is an isotope? You're going to compare it back to the periodic table. Look at your periodic table. See if the masses are the same. If the masses aren't the same, then you know you have an isotope. Are isotopes stable? No. And they're not stable when the protons do not equal the neutrons. they should all match in number. I'm going to pause this video because my video is fixing to come to an end. I can only record 15 minutes at a time, so